chemists, let's just review hydrogen bonds, and generally let's review ionic versus covalent bonds. So a molecule of water, H2O, consists of 2 hydrogen and 1 oxygen. If you remember, oxygen in this case is the bigger brother, the bully, and it's pulling more of the shared electrons, to itself. So when you do that, you get a negative feeling. When you take things from people, you get a negative feeling. So the oxygen is slightly negative, and the hydrogen is giving the teddy bear to the older bully, and therefore it has a positive feeling. So this causes water to have a slight charge where the oxygen molecule is slightly negative and those little hydrogens are slightly positive. So they will bond to each other. The oxygen and the hydrogen on other H2O molecules will bond to each other. Overall, that's called a polar molecular charge. It's an uneven distribution of charges. So here is our hydrogen molecule, and they're going to...
Oxygen exerts a far stronger pull on the shared electrons than does hydrogen, and so the electrons spend more of their time closer to the oxygen atom. Because of this unequal sharing of electrons, the oxygen atom in a water molecule actually has a slight negative charge,
and
the hydrogen atom has a slight positive charge, even though the water molecule as a whole is neutral. Because of the unequal sharing of electrons and the resulting positive and negative poles, a water molecule is said to be polar. The polarity of water molecules causes them to be attracted to each other. Since the positively charged atom involved in this special type of attraction is always a hydrogen atom, this kind of bond between molecules is called a hydrogen bond. Each water molecule can hydrogen bond to 4 other water molecules. A hydrogen bond is weak and lasts only a tiny fraction of a second, but it takes a lot of energy to overcome the combined attraction of many hydrogen bonds. This explains water's great capacity to store heat, its high boiling point, surface tension, and several other unusual properties.
So basically, water's amazing. It does all kinds of cool things, keeps you alive in various ways. So again, here's the big picture. They're not sharing equally, thus your hydrogen ends up having a slightly positive charge because when you give things to people, it gives you a positive feeling. And oxygen, the bully, has a negative charge, and they combine. Again, they're weak separately, but together they're strong. Like I can flick water at you, it doesn't hurt. You belly flap into a pool, there's going to be red. Okay. Chemical reactions. So a little, again, review. Cells constantly arranged. They're breaking chemical bonds, trying to be full in their outer shell. Everybody wants to be a noble gas. They want their outer shell to be full. That's what we're all trying to do. These chemical reactions are happening. They're breaking chemical bonds, forming new ones, all in an effort to keep their outer shell full and stable. These changes in chemical composition are called chemical reactions. In the reactions, you're going to have a reactant and a product. So whatever you start with, I have a cup of water, right? If my cup of water is the starting material, it's my reactant. If I put Kool-Aid in here, that's what ends up at the end is a Kool-Aid. So my reactants would be the water and the Kool-Aid. The end material would be a Kool-Aid smoothie or whatever it is that I'm making. I don't think there's Kool-Aid smoothies, but it's like a Kool-Aid mixture. So it's what you put in for the reactants, and the end is the product. If you wanted to do smoothie, you could put all the vegetables and the milk and the banana and whatever you're putting in. The end product is the product. Reactants, products. Chemical reactions, on the other hand, can rearrange the matter. You can put 2 things together and get salt. You can put 2 things together and get all kinds of interesting products, chemicals. However, matter cannot be created or destroyed. That's the law of thermodynamics. So we're not actually creating anything new. We're just combining them to create something more rearranged that has a different property. But we're not creating matter from nowhere. Life on Earth began in water and evolved there for 3 billion years before spreading onto land. Modern life is still very tied to water. Your cells are 70 to 95% water. The abundance of water is a major reason that Earth is habitable. Anytime we go and look at other places in the world, we are looking for water or some semblance of water so that the planet can be habitable and have life. We're going to talk about why water is so cool. So there are four reasons. Four reasons. You know this is going to come up in a multiple choice. It might even be like a short answer or an essay. There are four. Cohesion of water, which we're going to talk about next. The ability of water in a moderate temperature, which we'll talk about. The biology significance of floating ice. I got you this. Oh, my ice is melting. There's ice at the top. See it? There's ice cubes at the top. And the versatility of water as a solvent. Water molecules stick together as a result of hydrogen bonding. That's exactly what we just talked about, right? We've got the bully oxygen, slightly negative charge, and the hydrogen. So we know that water molecules stick to itself. It makes the cute little droplet. They stick together, and this is actually called cohesion. Together, they stick to each other. So water molecules will stick to each other. One of the ways we know this, you've all done it. Stick the straw in the thing, flip it over, right? And you still have water up here. I don't know if you can believe me, but there's still water at the top of the straw, right? It's cohesion, right? It's going all the way up the straw. You've done this in a restaurant, right? You put your finger here, you flip it over, boom, you still have water. And you can even see that I have little water droplets. See the water droplets there? That's hydrogen bonding. That's making them a little droplet. Trees depend on this for photosynthesis, for transportation of water and evaporation. So essentially the water molecules stick to each other through cohesion, and they kind of stick to the side of things through adhesion, and they make it all the way up to the top.
How does water get from the roots of a tree to its leaves? The evaporation of water from leaves moves water molecules up from the roots. The evaporation exerts a pull that is relayed downward along a string of water molecules from leaf to root. Hydrogen bonds cause water molecules to stick together, a phenomenon called cohesion. As each water molecule evaporates, it pulls on the next water molecule, and it pulls on the next. This relays the pull of evaporating water molecules all the way down to the roots. The cohesion of water helps to keep gravity from pulling the water molecules back down.
Cohesion. This is an actual cell. This is full of water up. I mean, trees, it's amazing, right? All the way up there. And here we've got some cohesion due to the water molecules. Huge trees, evapotranspiration. This is helping life exist. Surface tension is the next one. Basically, it's how difficult it is to break the surface of a liquid. So again, belly flop it into a pool and test this out. I can flick water at you, it doesn't hurt. You belly flop into a pool or a wave hits you, it hurts. Hydrogen bonds give that water an unusually high surface tension, so it's like smacking into something hard when you belly flop into a pool. It gives it a high surface tension and makes water behave as though it were coated with almost an invisible film. It makes it hard to break. And you've seen the little spiders and tiny little wood ducks. There are things that can just walk along the surface of the water because it has a high surface tension. Because of this also, hydrogen bonding makes water hard to resist temperature change. But we will talk about that in the next video.